Okay, hello everybody. Thank you guys for joining today on a lovely Monday, whatever time zone you are. This is another developer workshop. Hopefully this time running in conjunction with Scroll Open. If you guys are not familiar, it's our 6-week hackathon. So please start working with Arcana. We'll find out about it in just a few seconds to really power up your submissions. So without further ado, hi, I'm Emily. I lead the DevRel team here at Scroll. But I'm going to let our lovely guest introduce himself because I won't do him as much justice as he can do himself.
You're far too kind. Yeah, thanks for having us here, Emily. Thanks to you and the Scroll team. I'm Mayur. I'm the founder and CEO here at Arcana. We've been building all kinds of like developer tooling at Arcana for the past 4 years now. We like to think of ourselves as being in the business of abstractions, where we'd like to build anything that makes the lives of developers and users much easier in the Web3 space. So yeah, that's sort of like what we've been up to, and we're kind of trying to push that envelope with the chain abstraction stuff we have going right now.
Yeah, so I mean, I think if we could dive in maybe a little deeper for people who aren't familiar with maybe some buzzwords in the space. Chain abstraction, what is that? Why build it now or pursue, this avenue?
Yeah, so this is something that we started to think about middle of 2023. So it's just for some context here. So what we started doing at Arcana first was like wallet abstraction, private key abstraction, that sort of stuff, where apps that integrate with our SDK can just allow the users to sign into those apps with very familiar means like email and social login and things like that. So you're abstracting away the complexity that comes with third-party wallets, private keys, seed phrases, all of that, because the Arcana network would give these users a non-custodial wallet right in the app on the back of a Gmail login, for example. And that sort of, if you think about it, that was taking users from like the sort of landing page to the home page, and then we did gas abstractions where developers could sponsor gas. So now you're allowing users to do a bunch of interactions on the homepage and getting through to checkout, right? And then is when we started to think about, okay, what's like the ideal checkout flow? What should it be like? Web 2 has great checkout flows nowadays, with Stripe and all of these sorts of things. So we were like, can we model something along the lines of what the experience that a user gets with something like a credit card or a debit card and a Stripe, right? Um, and we figured that this doesn't exist in Web3, and so much so that I have all of these different sort of asset balances that are fragmented now across various chains, all the different L2s, perhaps alt L1s, and all of those sorts of places. And there was really no easy way for me to spend those assets. So we figured that this was a problem. And then in the beginning of 2024, people started calling this problem chain abstraction. We were like, very cool. This is validation for us. We're thinking on the right lines because someone wants to create an industry out of this. And we sort of doubled down since then. And what chain abstraction is, it's coming back to your initial question. According to us, it has various definitions. But I think the simplest one is what the guys at Particle Network like to say is, which is any way to basically allow the user to kind of move assets without explicitly needing to bridge, or the manual processes of needing to bridge, is probably chain abstraction. We like to think of it as any way in which you can unify a user's asset balances across the different chains and allow them to spend those unified balances as one near instantly without needing to explicitly bridge, is chain abstraction. So that's how we like to sort of define it.
Yeah, no, that was super helpful. I feel like it's definitely solving a big UX problem, which I also want to say we were doing a feedback session on Friday for all of our devs, and they're asking about like, oh, how can we improve and blah, blah, blah. And I think generally the answer was always like, how do you make sure this is a really good idea, but it's very complex what you're working on, right? How do you make this simple? How do you make this easier? And a lot of people are also tossing around, I guess, like wallet abstraction, social logins, and things like that.
Yeah,
So just to
yeah.
clarify, are you guys still offering that functionality? And if our devs who are looking at like wallet abstraction, gas sponsorship, we can still, let's forget chain abstraction in the topic of this interview, but Arcana is also offers that flexibility, right?
Yeah, wallet abstraction we do. Gas abstraction not anymore, because we don't think gas abstraction on the back of like ERC4337 makes sense anymore, given the direction which the Ethereum community is going with 7702 basically on the horizon. And that is so much more powerful, and perhaps, hopefully, is like a cleaner way to achieve account abstraction than 4337 ever was. So once that happens, we'll probably offer that up as well. Uh, but yeah, the wallet abstraction is available. It's running a bunch of apps and projects that use it today in production. So yeah.
Yeah. Sorry to derail again because I love talking to people like you who just drop random acronyms. So again, for maybe people who are like joining for their first time, I want to say most people know what 4337 is, but I mean, let's just pretend like, you said these things. Can you give a little bit of a also high level explanation of what this means for developers working with Arcana, this like changeover? What is 4337? What is 7702? Was that the number?
Yeah,
Yeah.
that's correct. Yeah, so I think account abstraction as a topic, as a subject, is a very important one, especially in the Ethereum space. It's basically, how do you separate an account from a signer? So in the Ethereum world, those two are merged. They're one. So your account and your private key with which you sign are like the private key with which you sign stuff leads to the account that you are signing against. But this sort of starts to create a bunch of different problems, um, and which is why, without going into the details of what those problems are, the Ethereum community came up with this whole idea of separating the two and abstracting away the account from the signer, and hence account abstraction. And so the first like major sort of EIP, or basically Ethereum improvement proposal that went through and started to get adoption was ERC 4 or EIP 4337, which uh, which basically sort of achieved this, but in a very, I don't want to say substandard, but in a way which I don't know, which created a lot more problems, and which is why you don't see a lot of these smart contract wallets, which were now your new account separated from your signer, which is still your private key, are were separated out in a way where they didn't offer portability. Like every new app that you went to, you had a new smart contract wallet created for you. They required you to kind of basically deposit funds into this smart contract wallet before you even started doing anything with it. So all of these caused probably more friction than actual solutions. They work well in isolation, or basically like the the what do you call it, the cocoon of an app. But for users, it was slightly pointless, because you couldn't take those funds that you deposited in one smart contract wallet over to the other without explicitly again transferring funds. So that sort of problem and a bunch of other things sort of started to become evident. And once the hype around ERC4337 died down, is when people started to kind of come forward and speak up against all of its shortcomings. And then it became clear that something better was needed, and there were a few proposals that 4337 sort of like superseded, which started to kind of gain prominence because they offered a much cleaner, better way to do things. And those have now culminated into this new EIP 7702, which is now an ERC, out to be released when Ethereum upgrades. It puts out the Petra upgrade. And this is a very neat way, at least on the face of it, to kind of achieve this sort of separation. And what's very nice about it that we really like is that it gives a very like 0 to 1 sort of step for people to move to account abstraction and smart accounts and smart contract wallets or whatever other combination of words you want to call that account. Because basically it says your existing account that all of us have probably in our MetaMask or Rabby or whatever can on the fly in the course of a transaction become a smart account. And that basically means that I don't need to move funds in advance. I can still achieve like batching of these transactions so that I don't have to do allowance and the submission of the transaction, which is a big pain in the Ethereum world, and all the other very cool thing, gas sponsorships, all of those things can happen. But I don't have to like create one account. It's my existing wallet address that just becomes this thing, right? So, and I get all these benefits. So that's what the whole thing around 7702 is about, and we are really excited for it. It's going to really help a bunch of different things that we are doing on the chain abstraction side, but in generally for users, especially in the EVM world.
Yeah. Awesome. Thank you for letting me take a bit of a detour there. I don't know if I went off rails, but that was super helpful. And just to also double confirm, this is on its way out. So, I mean, not usable right now, but everyone should be keeping an eye on Arcana and
Yeah,
seeing. Okay.
yeah.
Cool. I guess question, feel free to say this is not allowed to be said out loud. Is this something that will come out within the next 5 weeks that devs during our hackathon can use? Or
I
can you
think
say
so.
okay.
Let me look that up.
Guys, is this alpha? I'm not sure. But
Yeah. No, the Pectra upgrade goes live later this month, and I think we're going to have to spend some time, so probably not 5 weeks. So
okay,
yeah,
okay. No worries. I guess also shout out if you guys don't know, Scroll Campus, which is gonna be our 8-week IRL fellowship, will be happening a month after Scroll open end. So if you get into that program, then I'm hoping, I guess at that point it would be 12 plus 17 weeks from now, maybe we'll be able to get our hands on it. But
yeah,
let's forget about that. Let's get back on topic. Chain abstraction 101. I think you gave us the one-on-one in the beginning. Something I always love to talk about with projects working in this space is kind of just like a glimpse into the work in the background, right? Like,
yeah.
how does Arcana chain abstraction work? Like, how did we get to where we are today?
Okay. I'm going to actually sort of draw this out while we are speaking, and hopefully that should help people a bit better. So I'll just share my screen. This should
Okay.
come up.
Yes. Let me bring that up. Okay. Yeah. Perfect. I was hoping you had a visual because I'm sure it's very complex and hard to just like say out loud.
It's actually quite simple. I really like the design for its simplicity, but that's just me. I'm fairly biased. But you tell me what you think at the end of it.
Okay, cool.
So so fundamentally, what happens is every user has a wallet, right? So this could be MetaMask or whatever, and this wallet is what uh, interacts with apps, and apps are usually deployed on some chain, let's say chain B, right? And this is effectively like a two-way communication that happens between these two, where the wallet and is talking to the app. The app has a contract deployed on chain B, and basically the wallet talks to it, signs stuff, is spending assets that it has on chain B in order to kind of make things happen on this particular app. So this has been the case so far. So builders building on Scroll will probably have a contract deployed on Scroll, have a front end, and there'll be, say, MetaMask that their users are using to connect to this app and spend the Scroll assets. Now, the if you have to sort of think of what sort of assets the user has. Uh, what if there's a new app that really blows up on scroll, but the user does not have assets on scroll, right? So let's say they have assets on some of the other chains that have been there for longer than scroll has. For example, let's say OP and Arbitrum, right? So what I would need to do is, okay, let's sort of like map this out. So on OP, user has USDC, let's say 20, uh, and on Arbitrum, user has another 20 USDC that they need to be able to kind of, they want to spend. And on scroll, let's just say they have 0. Now, if the user wanted to kind of interact with this app and kind of spend assets here, now the first thing they need to do is head over to a bridge. So this is an OP to scroll bridge and
Oh,
move.
we have a comment. Can we zoom in a bit?
Okay. That's a lot. Yeah.
Okay, perfect.
All right. So I have this bridge and I have an R to O scroll bridge. And now my wallet is basically, talking to these two different things to be able to kind of make this happen. I need to kind of move these assets, and then finally I will have 0, 0, and 40. So what I had to do to kind of make all of this possible was go to one or maybe two different interfaces away from this app and manually move 20 USDC from OP to scroll, then manually move 20 USDC from R to scroll, and then I have the 40 USDC that I can now spend on this app on chain B. Instead of chain B, just call it scroll. Right. So this is the status quo, and the more fragmented my assets are, the more problematic it is. I have to go to more different interfaces, do individual bridge transactions before anything else can happen. Now, this is wholly problematic. So how do we kind of get past this, right? So how do you eliminate this manual process of bridging, essentially? So this is where Arcana comes in. So what we sort of put together as a design is we have the Arcana network, which is a Cosmos-based app chain, and its job is it's essentially like a state machine. It keeps the state of what we call user intents, and we'll talk a bit more about what those are. And what we also do is we have the Arcana vault contracts that we deploy on every chain that we support. And these are essentially escrow contracts. They hold funds on behalf of the user. So similarly, we'll have, the Arbitrum deployment, and also we'll have a Arcana vault contract on scroll like we do right now. So this is sort of like what we have, and beyond this, what we also have is what we will call as the Arcana solvers. So now what we do is, now if we go back to the original state where this user has 20, 20, and 0. Now, when the user needs to actually spend, let's say, whatever, this 40 USDC, we call that intention for the user to spend as basically an intent. And that is what the user submits to the Arcana network. And like I said, it's a state machine. So it records this intent and says the user is intending to use 20 USDC from their OP balance, 20 USDC from their Arbitrum balance to spend 40 USDC on an app on Scroll. That is the intent. And that's when that intent gets logged in our state machine. And that's when things start to happen. Now, the state machine is responsible for basically orchestrating the rest of the flow. So the next step is for basically the first collection of 20 USDC to happen. And parallelly, it also does this other collection of 20 USDC onto Arbitrum from the user's wallet. Now, once these funds are escrowed on these two contracts, this basically sends out like a sort of, you could say, an event to the Arcana solvers. Now, the Arcana solvers are essentially liquidity providers. You can think of them as LPs who front liquidity on the destination chain based on the user's intent, so that the user can get the funds that they need without having to explicitly bridge their assets and wait for that bridge or switch context. Now, as soon as they receive this information that these funds have been escrowed, they now start to fill intent, which is basically send 40 USDC over here. And now this money basically just passes through and comes down into my wallet on the Scroll side, and I am able to kind of go ahead and submit my transaction on this app on Scroll. And all of this happens without me ever leaving this interface that I'm on. Everything just gets managed for me. I've just clicked just a couple of buttons to ensure that all of this just happens. It happens with my existing wallet. I don't have to go anywhere, do anything. It's just a few button clicks. And basically all of this just happens in the background, and I'm able to go ahead and proceed to do whatever I intended to do on this app on Scroll. So this sort of intent solver architecture is what we employ to kind of make chain abstraction happen, where a user is coming, they have assets on any chain, but they're fundamentally being able to kind of spend that combined asset on any other chain that they want to, without having to switch context. So that's what we make possible.
Awesome. Wow, this is so clear. You did a really good job. I think I have a few kind of follow-up questions when it comes to the details, right? What kind of implications does this have on, let's say, gas cost, right? Because let's say in the original form, it would be okay, I have to pay the transaction fee to bridge for OP, and then I have to bridge for ARB, and then I have to bridge and then combine everything. Yeah.
So fundamentally what you would be doing is originally is you would have to do bridge TX of ARB to Scroll, a bridge TX of OP to Scroll, and both of these have gas costs, and these depend completely on the bridge implementation, where you'll be spending gas to call the bridge transaction, and then you're waiting for the bridge to kind of do its thing, and finally you end up with assets, and then you do this other thing, and these are separate transactions with their own gas. And so what we do now is, in the chain abstracted world, is there is a collection on OP, a collection on ARB, and a fill on Scroll. Now, if you think about this, these are essentially either basic ETH transfers, depending on what asset I want to kind of spend. In case of USDC, it's a standard it's basically like a ERC20 transfer. So you would be paying probably lesser in terms of gas because even this is just a transfer. And you would actually, it's actually more optimized. And the good part about all of this is if I need this USDC and I need to submit this transaction on scroll, I need even the gas token, which I may be missing. So what could additionally happen here is it sends me 0.0001 ETH for gas. And what I am going to be doing is I'm going to be sending 20.05 USDC. So in order for me to get the ETH on scroll plus the 40 USDC that I want to spend, I can get that from my solver on the scroll chain, but I pay in USDC the whatever is the gas cost that I have to incur for submitting this transaction, which would be whatever it is normally. But I don't even need to hold ETH on the destination chain for me to kind of make all of this happen. So that's sort of like how the gas situation is with chain abstraction and the way we've implemented it at least.
Okay, cool. I have follow-up questions, but we also have some questions in the chat. So I guess attendees take precedence over me. Nisha has a question. I think Cosmos has a 14-day lockup of some sorts. Would it apply here anywhere in the process?
No, not at all. So all this does is it's basically keeping track of the state machine that is of the intent state, and that's all it's there for. If you see in any of this flow, actually as such, what happens is that we bring some of this data, like this collection data, on chain, like this fill data, we bring it on chain, but none of this comes in the way of the user getting the funds in order to transact. So what we've done is sort of delayed bringing all of that stuff on chain, but it really does not matter because this does not interact as such in a way which requires anyone to like sort of build their application with this in mind. This is completely abstracted away for the user. All they have to do is effectively just have the Arcana SDK sort of Arcana SDK. Sorry. Just installed here, and that's it. There, you don't have to deploy a contract to our chain. There is no implication of any sort of like the staking on our chain or vesting on our chain on the app that is integrating our SDK to enable this for their users. So yeah, I hope that answers that.
Awesome. More follow-up questions. I guess for someone who's building something very specific. Goal is to buy an NFT on Scroll for 30 USDC. Would this be one transaction on Cosmos that transfers 20 USD, 10, etc., that move to the minter on Scroll? And how does this impact allowance transactions on OP and ARB?
Yeah. So if you wanted to spend 40 USDC, you would obviously. So the way we do it is actually you're not transferring funds when it's an ERC20. You are not actually transferring the funds from your wallet. You've given these contracts allowances, and basically they're pulling the funds from your wallet based on whatever your intent was. So this collection essentially happens through a pull from your wallet based on the allowances that you've already set. These allowances can be set beforehand, where you basically give infinite allowance to these vaults, or they get set on the fly. Now, the thing with setting this on the fly is, of course, these are button clicks for the user. They have to worry about having gas on the chain and things like that. So if basically you do a one-time setup of the allowance for the user, then this can be collected. In the case of ETH and not USDC, this basically just is a direct transfer from your wallet that you initiate. And suppose this was 0.2 ETH and 0.2 ETH, you do two like send transactions from your wallet, and then the rest just happens. In fact, this exact same use case that you're talking about is what I will showcase in our workshop right now.
Oh, awesome. Well, okay, before we dive in the workshop, I have like a few more questions if that's all right.
Yeah,
Um,
sure.
cool. So in the bridge world, I guess going back to like one of the concerns about bridging, right, is obviously security. I'm wondering kind of what you guys do in terms of security protections, or if it's safer, right? Probably, I'm assuming it is because you're not doing so many bridging
Yeah,
transactions
yeah.
on the Arcana side.
Yeah, so fundamentally, what you're doing in this entire flow, if you think about it, is you're moving risk away from the user all the way up to the solver. The solver is the one that is fronting this liquidity with the hopes that, essentially these funds are eventually settled back to it. So what we do is, because as the protocol and the service provider, essentially in this case, is the solvers are essentially sort of placing trust in these contracts, and the way the protocol is built out, and all of this is of course open source, will be audited. Right now we're in testnet, before going to mainnet it will be audited. And the idea is that as soon as these sort of like deposits happen, the solver is now saying that, okay, so the user's funds are now locked in, they're escrowed. There's a resource lock placed on the user's funds, so the user cannot double spend them. And then consequently, they go ahead to proceed to fill my intent that of 40 USDC. On the user side, what happens is that if this collection were to happen, and if a solver does not fill, if no solver fills their intent, then these contracts essentially refund the money back to the wallet. And this happens like every 10 minutes or so, where we calculate any sort of refunds that are, any settlements that are pending, and we just settle them back if in case the fill for the user was not done. So the user will, in case of like a failed intent, there is an inconvenience. For the solver, basically, as long as these funds are collected and they go ahead and fill, and the Arcana state machine is saying that this particular solver filled this intent, then it will settle back whatever funds are due, with of course some fee that these solvers are owed for basically providing the service.
Cool. And then my final question is whether or not you guys also do like any sort of swaps, right? So let's assume I only have $20 worth of frog,
Mhm.
right? Is that part of it, or is the assumption here that I will have enough like USDC in my wallet to fund?
Yeah, so this is something that we are going to get to. So right
Mm-hmm.
now you have USDC on other chains, you spend USDC. You have ETH on other chains, you spend ETH. You have USDT on other chains, you spend USDT. So that's how we've structured it. But obviously the idea is I have ETH, USDC, and USDT, but I want to spend SOL.
Right.
Right? That is the next step of evolution for the chain abstraction protocol, where we can actually make that happen. There are a couple of ways in which we can do this. One is obviously, like you intuitively guess, it's a swap to some sort of base asset, whereby my USDC, USDT, and ETH gets converted to some base asset, and then that base asset is what the solver supply on the destination chain, but it goes through a swap to give me the SOL that I need to be actually go ahead and complete my intended transaction. So that is something that we are working on right now, and it'll be available in the near future.
Okay. Awesome. Hopefully also within 17 weeks. If not, that's fine. We're building for longevity here, so whenever it comes out, um, we'll keep an eye. So if there's no more questions, I mean, obviously, keep asking throughout the stream, but let's dive into the workshop and see how people can actually start using this right now.
Cool, yeah. Let me just see if I have everything set up here. Um, yeah, looks like we are good to go. I'll share my screen here again. Let me know once you can see it.
Okay, we are live. I can see it, but I imagine we probably need to zoom in a bit.
Yeah, we'll do that. Okay, so what we have here is a very simple NFT mint that we're going to be doing. I've already sort of like imported this code. There's a GitHub repository for this code base. I'll share that with you. Maybe you can share it with your audience and the community to basically try this out. So let's basically let's get this up and running, and we'll take a look at it over here. All right. So yeah, so what you can see here is a very simple, extremely basic NFT mint site. What it does is it shows you this NFT. It says the price to mint it is 0.0005 ETH, and this is on the Scroll blockchain. I've deployed the contract on the Scroll mainnet. It's a simple ERC721. And when I connect my wallet, what it shows me is my ETH balance on Scroll, and it basically says I have insufficient balance to be able to mint this. Now, if I head over and kind of check out this account here on DBank's sort of portfolio viewer, I have a lot more in assets that are spread out across different chains. On Scroll, like you saw, I had the 0.401 ETH, which is too less for me to do anything about. But if I head over to Arbitrum, I have more ETH here. I have more than what I need to mint that NFT. If I check OP, I have more, even more ETH. If I go to Ethereum, I have more. So basically, all of these chains that we support, I have enough to be able to kind of mint this, but I just don't have it on Scroll. So now, what I would have to do is to head over to some sort of bridging interface and start to bridge assets over, perhaps from Arbitrum to Scroll, in order for me to have enough ETH to be able to kind of mint this NFT, right? But let's try and remove that sort of friction and try and get to a place where the user doesn't have to kind of even ever leave this sort of interface at all. So the first thing we'll do here is basically I have some notes here that I'm just going to use to copy paste a bunch of different things. Step one is installing the Arcana Chain Abstraction SDK. I just go ahead and do that here. And once I have that, very soon, come on.
This is just internet.
Yep, almost there. Yes, there we go. All right, so we have Arcana Chain Abstraction SDK installed. So next, we just need to kind of create an instance of the chain abstraction element, basically in our app. So I'll head over to my utils that I have here. Wait, hold on. I think it was this. Yeah, okay. Okay. I just put this here. I obviously need to import this. There we go. And I need to just export this getCA instance. Go back here. Okay, so step one done. Now that we have this done, let's fix this also. There we go. Now, the next thing that we'll try and do is basically get get and show the unified balance. So right now, what you see here is just my balance, ETH balance on scroll. Can we show the unified balance to the user where it basically shows them all their ETH across all the different chains that we support? So let's head over to our use wallets hook. Oh, not this. Um, our wallet provider, no, wallet connect. Yeah. So we come down here and I need to basically initialize the chain abstraction first and foremost. And oops. Oh, let me just quickly find where that is. Okay. Okay, I must say that most of this stuff is, yeah, okay. This is not it. Abba, ba, ba, ba. This is done. This is not it. Wallet connect. This ain't it either. Sorry, I'm a little stuck. I seem to have forgotten. It's, I'm just such a horrible dev, and it's all thanks to the team here that uh, I've been able to kind of get this far. But
No worries, no worries. I mean, you will have, like, a complete GitHub repo with all of the correct code, so
yeah, I do.
it doesn't
I
feel
do. I
live,
have that as backup.
right? Yeah,
I
that's
have it as backup.
we're
Yeah.
real people.
I'm just going to jump to that so that you can see what's, yeah, there we go. So, um, first thing we've done is we obviously did the utils part where we set up the CA and we're exporting the get CA. We're going to get end up using that. So yeah. So what we do is in this sort of like this hook for use wallets, what we are doing essentially is fetching the balance and we're showing it. So if you kind of compare what we have with what it should be, so right now I simply am getting the balance uh, from like from my window.ethereum, and I'm able to kind of just show it as it is. But what we want is to be able to show like the unified balance over here. So so if I go to my wallet, yeah, you see this here, this very standard ways in which I'm just using my ethers to be able to fetch the balances. But what we want is to be able to get this unified balance. So what all we need to do is to initialize this CA using the get CA instance. And once we've initialized it, all we have to just make this simple call to this SDK method, which says get unified balance. And I specify what asset I want to. I can specify an array of assets or for all the assets that we support. And once I have that up and running, basically we can convert our existing balance that we are showing to the user from just the scroll balance to this now unified balance that we have over here, right? So this is what, if I were to show you guys what that looks like on this other instance that I have running. and I connect my wallet here, it's going to ask me to sign in, simple CV signature. And now if you can see here, it shows me my unified ETH balance here for the same account, for literally the same thing, but now it's spread across different chains. But again, this is chain abstraction. You don't even have to tell the user what chain they're on, in a sense. And while here, I could not mint this asset because I had insufficient balance, I have more than enough balance here to be able to go ahead and mint it. So now the next thing that I need to be able to do is basically, once we're showing this sort of unified balance, next is to basically set up this check of whether I need to do chain abstraction or not in order to kind of proceed and take things forward. So if I go to my page here, it's just a single page site. So what we have here is this NFT minter function, in which all we are doing is we are again sort of getting this CA instance from get CA, and sorry, hold on, it's here. Yeah. So all I need to do is, instead of when I use this sort of create wallet client to be able to write transactions using VM, I specify the chain and I say I'm using a custom provider, which is the Arcana CA, which we've instantiated here. And then all I need to do is just call my transaction, this write operation to this contract where I'm going to be doing the mint. And because it's using the custom provider, it checks, the SDK checks internally if you have the funds or not to be able to kind of call this mint function. But if you don't have, then all it's going to do is going to do the chain abstraction bits for the user, and then make sure that the user has the funds on the scroll chain, just like how I described it in my diagram there, and then consequently go ahead to submit this transaction. You have to change absolutely nothing in your code except for basically saying, instead of using window.ethereum, you're using the custom CA provider over here. That's basically all the change that you need to be able to do. Most of the change that you need to do is essentially UI stuff. Like, you want to be able to show the user the intent and for them to sign up on it. So you kind of need some React handling for that. You need to be able to kind of show that intent in a dialog box, which we'll see very shortly. And it's just front-end code that you need to write to be able to kind of handle this now multi-chain experience that you're giving to your users. So if you kind of try and see it in action, right? So what happens is, when I hit, in fact, we can just open the console so people can see what's happening. I hit the mint button. What we're going to show this user is that, okay, so you want to spend 0.005 ETH on Scroll. You have very little on Scroll, but you have more on Arbitrum. And basically, for a fee, we can make all of this happen, right? And so for this total fee of 0.00002 ETH, which basically comes from my Arbitrum balance, I can go ahead and make this happen. So all I will do is say allow. And once that gets done, this is my initial signature off to our Cosmos chain, which basically creates the intent. You can see here, it's created the intent. Now, once that is done, I'm going to sign off on the ETH transfer from my Arbitrum one. Again, I didn't have to click any buttons to change chain, nothing like that. My funds are going to get collected from my Arbitrum balance, go into the escrow contract. And once that is done, a solver will fund me the 0.005 ETH, basically the liquidity that I'm missing on the Scroll side to be able to kind of make this happen. And then once I have it, I can go ahead and submit this transaction as well. So just hold on. Let me just try that again. Okay, initial creation of the intent, that will get done. You present the user with And there we go. I've basically submitted my assets on the Arbitrum side. I'll receive them on the scroll side. And as soon as that happens, I'll be able to do my final transaction here. I've got the ETH necessary to complete the mint. I go ahead and hit confirm. Now my NFT is going to get minted on scroll. I can see it happen. All gets done. So I basically clicked three buttons, and I was able to use assets on different chains to be able to spend on scroll to be able to mint this NFT. And now if you go check it out, I've been minting a bunch, but you should be able to see it. Yeah, this is the okay, this is the oldest. This is the newest one, number 5, that just got minted over here. So yeah, this is what you can basically do with the Arcana Chain Abstraction SDK.
Awesome. Well, that was very simple, which is good. Um,
Yeah,
yeah, I actually do have another question that kind of popped up in my head was, do you guys do like priority for which chains you source
yeah,
from?
yeah. So we do actually, and it's let me just come back here. So right now we have an internal way of trying to figure out which chains is do I have the user have funds on. Okay, so these are the chains. What is the gas price on each of these chains? And we sort of order that up and start taking assets from those chains in that order. But
Mm,
this is something that with newer versions of the SDK, we're going to change up, which will basically allow the user to be able to uh, pick the chains, or rather exclude chains that they don't want the chain abstraction protocol to use. And then it'll just sort of readjust the fees and everything
mm,
else. So all of this happens on the intent creation time. So you can adjust things, slide things up and down, exclude things, and then just hit confirm, and then it'll just do a bunch of things for you. So yeah, that's sort of like the idea.
awesome. Yeah, I was gonna say, I was like, I wonder there's perverse incentives for chains to be more expensive so that you don't withdraw from them. But yeah, no, thank you so much. This is, like I mentioned, it was very easy, it was very clear. Feel free to send me the GitHub
Yeah.
link afterwards. I just wanted to say some, like, shout out some fun chats from the comment. Anonymous LinkedIn user, bullish on Arcana. Um, what is it? Impressive, so good, well explained. You feel the passion and genuineness of the host. It just pours out of them. Yeah, this workshop is a must for builders. Yeah, so I guess that's us bragging about ourselves. Last piece is, if we want to get connected, how do we, like, what is Arcana's Twitter, your website that I can just like plop in and flash on the screen?
Yeah, so our Twitter is at Arcana Network. DMs are open. You can always reach out. The multiple people who look at that account, so things filter through eventually for sure. Our website is arcana.network. There's some contact information there as well. So you can definitely reach out through various channels. We have a Telegram group. You can reach out to us there. But yeah, if you want to look up the docs, then it's just docs.arcana.network. You can just head over there. We have a cute little chat bot that'll help you find your way. But if they're not doing a good enough job, a human at Arcana is never far away. You can reach out to me. You can reach out to um, just our handles or any of our official sort of social sites, and we'll find you and we'll help you.
Oh, awesome. I guess also, if you're in our Scroll Builders chat, that's where I'm sitting, so you can bug me to bug
Yes.
Arcana. But that, don't abuse that privilege, or maybe do it. I don't know. But yes, last piece I wanted to say. Like I mentioned, hackathon is happening right now. If you guys didn't register, registrations are closed, but we are doing referral codes. So if you're still listening and you want to join Scroll Open, you can head to open.scroll.io. there's going to be an application. You'll have like either a referral code or a referral email. You can go ahead and put Arcana, all caps, and that will allow you to still join in. But yeah, I guess I'm gonna count down from 5 to count for YouTube lag, and if there's nothing else, I'm gonna let you go, and say thank you for your time. So 5, 4, 3, 2, 1. Okay, well, again, thank you so much for coming. Arcana Network on Twitter, docs.arcana.network. Have a great day, and I'm gonna let you go. So, bye.